Happy to see some of you actually got up early today. I'm very relieved. I was hoping I would have to speak to an empty room today. The party was good, I do agree. But we're talking about AI agents today, but since I know nobody after 5 hours of sleep wants to listen to an hour-long corporate presentation like this, I've done something that I've never done for an official presentation, and that is to actually theme the whole thing. So just give me 1 second. Howdy. There's a new sheriff in town, it's AI agents. And we're going to spend the next hour exploring a little bit what's been going on in the Wild West of AI in the recent weeks and months. Now, for those of you who I haven't met yet, my name is Henri. I work as the AI Partner Solution Architect at Microsoft Denmark, specifically focusing on Azure AI, which means that I work with all of our Microsoft partners here in Denmark when they're building AI solutions, machine learning, and those kind of things on the Microsoft Azure platform. Now, before we start for real, I've got a few little disclaimers that I want to share with all of you today. The first one being that this is obviously my first Codegarden. I'm very excited to be here, but that means I know very, very little about Umbraco. In fact, when I arrived here on Tuesday, I knew next to nothing about Umbraco. And today I know a lot more already, but it's still very close to nothing. So if you ask me questions that are related to Umbraco, expect to get very bad answers. Now, disclaimer number 2 out of 4 maybe, is that I'm also not a C# developer. So the only thing I've ever done in .NET was a little modification to Stardew Valley, because that's written in C#, and I wanted to put large language models into that, so I had to figure out how to do it in C#. That's the only thing I've ever done. So during the live demos later today, you guys will get to see some Python. Now I know you guys are probably, every C# developer is smart enough to read Python, right? So you should be good. But everything I'll show you, you can also do in .NET with the same libraries. That was disclaimer number 2. Number 3, I think this talk is being recorded. If you're watching the recording, it's probably out of date already. AI things are happening really, really quickly, so just be aware of that. Last disclaimer, we're doing cowboys and we're doing AI, and there's 2 things in that Venn diagram where those things overlap. One of them is this talk, the other thing is Westworld. Has anyone seen Westworld? Perfect, me neither. So there will be no references to Westworld in this talk whatsoever. I just wanted to put that out there. Great. All right, let me have a sip of coffee. You do that as well. I think we'll all need it. And we're going to start jumping a little bit into where this all started, this big AI gold rush. Now, I've been working with Microsoft for the past 8 years, so I've been, kind of seeing AI go from classic machine learning, where we're training, prediction models and those kind of things, all the way up to where we are today. And the most interesting thing probably was in 2021, when I first got my hands on a Microsoft internal preview of GPT-3. And that was about 12 months before the release of ChatGPT. So while data scientists and AI people and NLP professionals, we were happily hacking away with large language models, I would say, a greater community, the greater tech community, but also greater society itself, didn't really see yet what was going on until, of course, 2022, when suddenly ChatGPT rolled into town and took the world by storm. Since then, my life turned from, my work life, also my private life to some degree, turned from something that was focusing on AI and machine learning as a very broad topic to something that suddenly was just chatbots. Chatbots everywhere. Everybody suddenly wanted to build a chatbot, right? Everybody had seen ChatGPT, and now suddenly everybody wanted to build their own ChatGPT. So all I was doing was advising people on how they can build chatbots with large language models. And for the past few weeks and months, I've been on a little bit of a crusade against chatbots, because there's just too many of them, and I'm a little tired of building chatbots. So It's not because I don't think chatbots are good or AI is any good, but I think chatbots are a little bit like this thing here, which, by the way, the electromagnet existed at the same time as cowboys. Was invented in 1824. It's one of those things that you don't really think should have existed at the same time, right? But when exactly 200 years ago the electromagnet was invented, it was kind of the first real use of electricity. Now imagine what would have happened if people had just seen the electromagnet and then were like, that's pretty cool. That's a use for electricity. I guess that's everything we can do with electricity. Let's move on, right? Electricity checked off. And we would have never invented all of the other cool things you can do with electricity. This is a little bit where we are right now when it comes to chatbots. We have large language models, and we're building all of these chatbots. But if we now just say, okay, chatbots are fine, we've done what we can do with generative AI, let's move on. Let's do quantum computing next, or something else. We might never find all of the really good, all of the value-creating opportunities out there that can make use of generative AI. Now, I would argue that generative AI, in fact, is a completely new milestone in the way we work with computers. And you can see that in some of the early examples of software that's coming out that's powered by AI. But you'll see that even more so in the near future. Just looking at where we came from. I mean, back in the cowboy days, we were programming computers, we were programming computers with punch cards, right? With the little hole punch cards. And those were terrible to program, of course, because it was really hard to know what you were doing. It was a little easier than 150 years later when we had command line interfaces. At least we could see what we could type, or what we typed. But it was still hard to know what could we actually do. There were only very few commands that are actually valid, right? If you just had to type something random on the keyboard, most likely it wouldn't actually work. That was then made easier with the rise of graphical interfaces. Suddenly we have a mouse, we have a cursor, we can see what we're doing, we can see the buttons, we can click. But ultimately, we still have to know how to operate the software. We have to know what buttons to click in what order to make something happen. Look at your Windows 11 or your iOS computer today, and you'll find it looks pretty much still exactly like this. Windows 95 interface. The only difference is that now the corners are rounded. Aside from that, more or less the same principle. And then we see, just a few years ago, this new type of interface emerge, the natural language interface. And here we don't need any buttons, or at least not a lot of them. Instead, we just have this text bar that says, ask me anything. And that's cool for the user. You can suddenly ask for whatever. And for the first time in the history of human-computer interaction, we are actually putting the responsibility of figuring out how to use the software from the user onto the software itself. You don't need to know how to operate this interface. You just type in what you want to happen, and it may or may not happen. But at least you don't have to understand what you're doing. Now, for users, this is great. But as developers, how do we design for anything? It's easy in a graphical user interface to say, my software has 3 functionalities. I'm going to have 3 buttons. But if the user can ask for anything, how do we make sure we can deliver anything? It's hard. This all is a very long intro to say that, oh, 1 second. It's Cowboy Clippy. And it looks like we're designing an AI application. Would you like some help? Well, let's see. Let's see if we need help. This Codegarden has been very much having the theme of democracy. So let's do some democracy. Who here in the room has ever encountered a Clippy pop-up like this without the cowboy hat? Yeah, keep your hands up. Good. Now, only keep your hands up if you have received helpful help from Clippy. There's one guy. I'm going to have to talk to you later because you might have had malware installed on your PC. Look, the thing is, Clippy has not been traditionally, for most people, a very helpful AI assistant, if you want to call it an AI assistant at all. It's not been a very helpful assistant. The thing is, Clippy is what I would call an interface for information. It would give you the same tips for writing a letter over and over again. But what it couldn't do is it couldn't write the letter for you. In fact, it couldn't even really do anything aside from just regurgitating those tips. And that's what's limiting the capabilities and the usefulness of Clippy to some degree, you could say. If you look at this in the context now, of course, Clippy is long dead, but there's still plenty of applications that have carried on Clippy's legacy. Because today, this is chatbots. Apps like ChatGPT are the Clippy of today. They can regurgitate a lot of information, but they can't actually help you do anything. So we need to go from interfaces for information to interfaces for action. We want to use AI not just to bring people information and data, but to bring people the ability to do something, to achieve something. So we need to go from chatbots to copilots. And when I say copilots here, I don't necessarily refer to the copilots that Microsoft is building. I'm referring to copilots as a generic term for AI assistants. But we are indeed building quite a lot of copilots at Microsoft. And our engineers, they've come up with this thing called the Microsoft Copilot Stack. And this is what we are using internally to build our own copilots, whether that's the Copilot in Microsoft 365 or any of the other copilots in the different products and services. But the Copilot Stack is also available for all of our customers and partners to use and build upon to make their own copilots and AI assistants. And this session could have easily been a session on how do we build copilots. But I didn't want to go there. I didn't want to just run through this entire stack with you and show you every little bit of it. Instead, I wanted to deep dive on one aspect of the stack that I personally find particularly interesting, and one aspect that has seen rapid development over the last couple weeks and months. And that's this bit here in the middle. It's the AI orchestration, the tool chain. Because, of course, we shouldn't discount the importance of data. Data is super important also today when we talk about generative AI. And we shouldn't discount the importance of foundation models. But what really changes the way our applications behave is how we chain all of that together and how we utilize tools to actually make that work. One of these patterns, development patterns, you could say, that has arisen for AI orchestration is AI agents. And the rest of the session today, we're going to be spending looking through different ways of building AI agents, what we can do, different, you could say, strategies for building AI agents, and maybe also actually start with what even makes AI agentic. We're going to also, if the stars align right, going to have some live demos as well, and maybe they will even work. We'll see. But first, a little bit of the boring part, definitions. What are AI agents? Now, if you're hoping to learn it from this slide, I hate to disappoint you, because I don't think our own definition is very good. According to the Microsoft documentation, AI agents are code or mechanisms, which is already quite vague, which act to achieve predetermined goals. Okay. Examples of AI agents can be found in the code of things like chatbots, smart homes, okay, and programmatic trading software used in finance. So it's a very vague description, and I don't think it helps us to really understand what AI agents are. Instead, let's dive into one of those examples that they gave here, and that's home automation. Coming back to this whole thing around interfaces for information or interfaces for action, let's say we want to light up the saloon. And if we are if we are interacting with an AI agent, we might say something like, please turn on the lights in the saloon. And what we expect to get is something like this. This isn't really anything new. I mean, your Google Home Assistant or your Alexa can probably do this already in your living room. But now that we're starting to work with generative AI, what you'll see a lot of applications do is something like this. You'll ask the same question, please turn on the light in the saloon, and you'll get some response like, certainly, here are some tips for doing that. First, locate the light switch, then press the light switch, then see if the light has turned on. Right? It's not very useful. That's not an AI agent. Because AI agents need tools to function. And what we don't have in that example I just gave is the tool to actually operate the light. Leaving software behind for a second and just thinking about how we as humans use tools, if we have some kind of problem, like let's say I want to hang up a picture of my horse, then I might have some tools in my toolbox. And from experience, or maybe from being taught, I know what these tools do. I know what these tools can be used for. Hammers can be used to drive nails into surfaces, pickaxes can be used to break rocks or stone, and wrenches can be used to tighten bolts and nuts. Now, because I have some level of human intelligence, I can figure out, well, hanging up a picture requires, likely, driving a nail somewhere, and then a hammer seems to be an appropriate tool. I could probably do it with another tool as well if I had to, but the hammer is obviously the most suitable for this task. Since large language models operate more or less the same way as I just have, reasoning over the description of a tool and the description of a task, we can do the same thing with AI. And we call this function calling. In this example here, let's say, once again, I want to turn on the lights. That might be the question that I have as a user. Turn on the lights. It's not a question in this case, it's more of a command, but it still works for the example. And then we use a large language model to detect the intent, turning on the light. And the large language model needs to know what kind of tools does it have available. It might have an API that allows it to control the light. If it knows that, and knows what this API is used for, because we've provided a description for it, and we know what the user wants, or the large language model knows what the user wants, it can then generate what we call a function call. And that allows me to then actually do what the AI wants to happen, or what it needs to happen in order to serve the user's request. Now, the API call to our light switch might return some kind of status code. We can provide that back to the large language model to let it then output some kind of response back to the user, something along the lines of, here you go, I've turned on the lights for you. And this function calling is fundamental to the way we build AI agents that can not only provide information, but they can actually do things. I want to show you a quick example of what that can look like. And I want to do that in the Azure AI Studio. Now, we don't have time today to kind of do a full deep dive into all of the different AI services on Azure and the full AI Studio. So all I'm gonna tell you for now is that essentially what we can do in the AI Studio is we can just access a wide range of different types of large language models, both from companies like OpenAI, but also plenty of open source models, make those available as an API that I can just call, and then play around with them a little bit in a GUI interface. So let's actually do that. First of all, let me try to get out of this presentation. There you go. Yes, perfect. Good. We're going to jump into the AI Studio. And over here, we've got a whole number of playgrounds. I'm going to try to make this a little bigger for you guys. 1 second. There we go. So I've got a whole number of playgrounds for all kinds of different things I might want to do. I might just want to chat. I have a playground for that. I might want to generate images. And we've got this assistance playground that actually allows me to do function calling we just talked about. No, this playground, I would use this mostly for trying something quickly, just seeing if something works before I actually go do it in code. Now, in this example here, I've got a number of deployments up here on my left, and right now we're using 3.5 Turbo because it's nice and snappy, but we could also use GPT 4.0, which just landed in Europe as well here a few days ago, so that's really nice. But we're going to stick with Turbo for now. And you can see here I named my assistant the Pony Express assistant, and I gave it some instructions. I told it to act like a post office worker in the Wild West, and that it should help me with my Pony Express questions. Also, I told it to please talk like a cowboy. And we can quickly test this. If I just say howdy, it'll reply in cowboy style. Very good. All right, so far we're just doing a very boring chatbot. In fact, you will probably find that this is not very interesting if you're just trying it like this. But what we can do, we can add tools. So over here, in the Tools tab, I've got a few things here. I've got file search and code interpreter. We'll get into that later. But we've got this little function here. We can add some functions. And one of them I've already added. It's called getDepartures. And these functions here, they are purely defined in JSON. This is only metadata. There's no actual code here, because we're just simulating this right now. I've got a name for the function. I call it getDepartures. I've got a description. And this is important. This is not developer documentation. This is actually what helps the large language model figure out when to call this function. As I determine the next date for the departure of the Pony Express to the provided location. All right, so I'm already hinting that this function needs some kind of input. Now, you can find that defined down here, actually, because I'm saying it has a property called location, and this location requires, well, this location is of type string, and it itself, the property, has a description. So this is being used then for the large language model to understand what kind of format are we actually expecting here. In my case, I say the city and the state, for example, Seattle, Washington. Now, I also set that as required because we need to know where to go. And this is really all it takes to define this little function. You can save that. And now, whenever we call the assistant over here in the chat window, it will know that there is this function called getDepartures that is used to get departures for the Pony Express. So if my question has anything to do with that, if I say, when's the next Pony Express to... Is anyone from the US here in the room? Yeah, where are you from?
Bellingham, Washington.
Well, that's... I'm not sure the Pony Express went there, but let's see. I'm just going to ask, when's the next Pony Express to Bellingham? And we'll see what happens. So what you see now, of course, it can't call or it can't execute my function because there's no actual code there. Instead, what it does, it prompts me to simulate the output. So you find here, it gives me this function call, getDepartures, and the location is Bellingham, Washington. Apparently there's only one Bellingham, or yours is the most famous because I didn't actually specify Washington, so that's nice. And now it just prompts me, as the system, so to speak, in this case, to provide some kind of response. I could make this like a nice kind of JSON, but it doesn't have to be. It's a large language model. It doesn't really care. But we could say the Pony Express goes, here we go, goes, actually, let's do the 14th of June, 1860, something like that. And we'll just reply back. And now what happens is that the large language model will then take that information and will provide a response that we can then show to the user. In this case, it says the next Pony Express to Bellingham, Washington is scheduled for June 14th, 1860. Yeehaw. Very good. But you could imagine that it gets very laborious if you have to make a function like this for every single thing that you might want your application to do. There's a lot of very basic things that we just, we as humans naturally assume AI can do, right? Generally, humans will assume that AI is good at math, or good at research, or good at art, or whatever. On the other hand, all of these large language models that power the AI applications, they're only good at one single thing, and that's language. So whenever a user goes into our application and asks a question that might require some kind of math, there's absolutely no guarantee that what they'll get back is any good. But you know who can do math really, really well? Classic, computers. Non-AI. We figured out how to do math in code easily forever, right? So let's leverage that rather than leaving it up to the large language model to do math or to do anything else, really. If we can solve it in a few lines of code, then we don't need the AI for it. Except that maybe we need the AI to actually write the code, because that's language again, and language, large language models are really good at. This is what this little toggle here is for, code interpreter. And the code interpreter allows us to actually, or rather it allows the large language model to write code, execute that code in a sandbox, and then keep on working with the result of that code. So let's say I wanna know how many days is it until the departure that the large language model just told me. I could ask a question like, how many days is that from today? And if you ask a question like this to a classic chatbot, it will, in the worst case, tell you something like, or it will make up something in the worst case. In the best case, it will tell you it doesn't know because it doesn't have access to the current date and stuff like that. Here you can see what we're getting back is from the code interpreter, and we can see exactly what kind of, I don't know, can I zoom in and then do this? Well, it doesn't get any bigger. But we can exactly see what code the code interpreter has actually written and then executed. This is Python. It imports the datetime module, which is kind of a requirement for this. It even, you can say it even commented its own code, so we can understand what it's doing. It's getting today's date. Then it gets the target date, which it got from the message history, and it calculates the difference in days. And that's what it then uses to reply to the user. It says, well, that's a mighty long time from today. It's 59,900 days till the next Pony Express. Now, what the AI is missing here is that this is 60,000 days in the past. So maybe we should just ask for clarification. Oh no, have I already missed it? Well now, I reckon you might have missed the mark by a few years there. The next Pony Express to Bellingham was back in 1860, and we are a bit past that now. But don't you fret, maybe we can find another way to get your message across. Well, maybe. So this was a little example of how we can actually utilize functions that we define to add capability to these large language models, but also to let it actually write its own code when we haven't defined a function for something that we can easily solve with a few lines of Python code, like, for example, date calculations, basic mathematics, those kind of things. String manipulation is another one that's very, very easy to do, but that we shouldn't really leave up to a large language model. Now, quickly back to the slides for just one tiny bit. 1 second. Because so far, what I've shown you was of course just in the graphical user interface. And that's cool and all for playing around and for the kind of type of experimentation we're doing today. What it's obviously not good at is when we want to build an actual application. Then we got to do that in code. And what we're using internally at Microsoft actually to build our copilots is this framework called Semantic Kernel. This is something that was developed by Microsoft and then open sourced, and is available for everybody to use as well in both C# and Python, and now most recently also in Java. The idea with Semantic Kernel is to kind of provide a little bit of a, you could say, an in-between, something that sits between all of the AI models and the other types of different data sources that you might want to connect to, that it actually provides connectors to as well out of the box, and all of the other things that maybe you're writing yourself in your application, all of your deterministic code, all of your functionality, all of your APIs, everything that allows these AI models to do something rather than just, to provide information. So we're going to have a quick look at that as well. And by the way, you can find the slides afterwards, and you can click through all of these links here if you want to get the code that I'm using, or at least some very similar code. It's not cowboy themed, unfortunately, but the quick starts are otherwise quite good. So let's jump into VS Code, and let me find, this is it. So I'm going to show you a little bit of Python code, but we're not going to go through this we're not going to go through this line by line. I'm just going to quickly walk you through what's happening. So essentially, we're setting up a kernel. Kernel is just kind of a thing that collects all of our different plugins, all of our different AI models, things like that. We're adding some AI models here. I'm using GPT-4o. We're adding an embedding model. That's quite important as well. Mostly so that the model can actually figure out which one of the functions are relevant. And then we're importing a whole bunch of plugins. Now, what's nice with Semantic Kernel is that it already has a lot of plugins that come out of the box. So we're talking about plugins for math, addition, subtraction, those kind of things, for text, string manipulation, and for time. So rather than having to first write the code, like what we just saw with the function, with the code interpreter in the studio, here we've got this code written already because, it's always going to be the same code. Addition is generally very, very similar every single time, right? So we don't need to waste AI resources on coming up with code that does addition. We also got the opportunity to add our own plugins. So I've written a little plugin here called the chat plugin. I'll just quickly show you what that looks like. It's what in Semantic Kernel is called a semantic plugin, because this actually doesn't contain any code. It just contains a little configuration file that determines what kind of input it has, and a prompt. So actually everything, let me actually show you the cowboy one instead. This plugin will actually just run this prompt. So in this case here, I said rewrite the input into Wild West style. And then it's allowing me to template, and the input will go down here. So whenever we're running this plugin, we're just running this prompt against the large language model. That's a semantic plugin, but there's also what are called native plugins. And these are, I think, the more interesting ones because they allow us to write some actual deterministic code and expose that to the large language model. In this example here, I am simulating a saloon. You could say maybe this is e-commerce, right? And here's a function that allows us to order a drink. We've got this little function decorator here, which essentially is just used to tell the kernel what this function is used for. I, of course, also named the function. It's called order drink, but I could name this anything. The kernel doesn't care. It only looks at what we're putting in this decorator. So when I say the description here is provide a drink at the saloon and add it to the tab, then the kernel will actually call this function whenever the user requests something along the lines of ordering a drink. Alongside the description of the function itself, I also define the inputs, and I annotate them here. It takes, what is it? What's it called? The drink, the type of drink to order, and I'm saying here in plain natural language what the options are, and it takes the amount, the number of drinks to be ordered. And then all I'm doing here is I'm putting it in a little dictionary if it's one of these three, and if not, I'll leave it be. So this is essentially what a plugin can look like. Very, very simple plugin. Now, what happens when we run this, run the application here, you will find that, well, so first of all, I get to say something. I build a little chat loop in there that asks me for my input. Let's just do something simple. We'll say howdy. And you can see I've left the logging enabled because it'll be interesting later. So it's maybe a little hard to see, but this is the reply we get back from the AI. Well, howdy there, partner. What brings you to those parts, these parts? Looking for a drink, some help, or just a friendly chat? And let's actually get a drink. I don't know how many of you are up for another or so soon already, but I could say 2 beers, please. And what should happen now is that we see in the logs here, there we go, it calls our saloon order drink function that we wrote with the following arguments: drink, beer, amount 2. This is perfectly fitting what we just asked for. And then we also get back an actual reply from the large language model. In this case, it says, 2 cold beers coming right up. Here you go, partner. Enjoy your drinks. Now, I also wrote a little function that lets me see my tab. So I can ask, what's my tab? And it should tell me there's currently 2 beers on my tab. You can see here it calls the saloon get tab function with no arguments because it doesn't take any arguments. And it says, your current tab shows 2 beers, no wine, no whiskey. All right, let us actually, still have a little bit of time left, quickly write our own function. Let's add a new function. I've got a little placeholder function down here. And we could say, get the price of a drink. And we can say the name is get price. And then down here, we'll say it takes, we'll just say it takes a string called drink. And then we will say, return placeholder function. This is GitHub Copilot doing a great job. Return the price of drink is $5. That's great, thanks. Perfect. And it's fine that it's called placeholder function, it doesn't matter. So now, whatever we're going to call this function with, it's just going to tell us the price is $5, which for Cowboy Times is probably quite steep, but we'll go with it. If I now run this again, because I've just added a new function to my plugin and I've already imported the plugin, it will already be available. If I ask, what is the price of a whiskey? You will see we call our function, our saloon get price function, with the arguments drink whiskey. And the response we get back is, well, partner, a fine shot of whiskey will set you back just $5. Want one? And now we could go and we could order one, but I think will spare us those. That was a quick demo on how we can utilize Semantic Kernel to actually build AI assistants that can execute actual native code. But the thing is, why should we just stop at a single AI agent? Applications like ChatGPT have kind of made us think that everything that's about generative AI has to be this linear back and forth between one human and one large language model. But that isn't always the best solution. Let me give you an example. Let's say I want to generate an image of a cowboy having a beer with his horse. And I tried this yesterday, and the output I got was this one. Now, those of you in the front, you've already seen this. It's a little weird for multiple reasons. Partially, it's the very strange way the horse wears the hat. The other one is, whose arm is that? So obviously, this is not a very good solution to my question, to my request. Now I could just say generative AI is terrible and it hallucinates and it makes too many mistakes. And that might be true, but I'm also not doing a lot to actually catch those mistakes, am I? I could maybe try again and say, look, give me a cowboy having a beer with his horse, but no gorilla arms this time. And what do you think happens when you do that? You get this. And I've tried again, and I've tried again, and I've tried again. And they get progressively worse. So obviously, this isn't the way to do it. Now, there is some image generation models where you can provide negative prompts, rather than just saying, don't do this. But I was using DALL-E, and DALL-E doesn't do that. So this is the best opportunity I had to do this. And this doesn't work. We need to do something else. What we find ourselves in is often this kind of iterative loop these days, where we as humans, we make some kind of request to the AI, and then the AI does something, and then we have to check whether it's good enough, and then it's probably not good enough, and we have to go back to the AI and tell it, please do this again, or change this, or something. And that's not only a waste of our human time, it's also, talking about sustainability, a waste of compute, and just generally a waste of resources. So what can we do? AI actually is not blind to its own failures. It just can't help it. Large language models, for example, they only ever generate forward. They generate the next token. They can never go back and fix something that they have previously generated. That's how hallucinations often happen. But if you gave a large language model a chance to correct itself, it often would. In fact, if I show this picture here to GPT-4o, which is multimodal, so it can understand pictures as well, and I said, I asked for an image matching the following prompt, a cowboy having a beer with his horse without gorilla arms. Please determine whether the attached image matches the prompt. Provide your reasoning. That was my prompt to GPT-4o, and the response I get back is, the attached image does not fully match the prompt. While it does feature a cowboy having a beer with his horse, the cowboy also has gorilla arms. There's once again a slight hallucination there, but it at least understands that this isn't really what I asked for. So we can actually utilize generative AI to, you could say, discriminate the output of generative AI itself. So rather than having this kind of iterative flow that always relies on us humans being in the loop, we can have some kind of a multi-agent flow. Why don't we have a human user that provides their input once to an AI, and then that AI acts as a moderator, you could say, on behalf of the human, and manages the exchange between one AI that generates the content and one AI agent that actually checks whether the content that was generated matches what the human was asking for. That way, I only have to provide my input once, and I only get one result back. That result that all of the agents agreed on was actually good enough for what I asked for. And now I'm, of course, talking about AI agents, but once you look at it this way, we don't have to really consider whether these are AI agents at all. They could be any kind of agent. You could easily imagine this architecture including a human that generates content, or a human that checks results. Or maybe the thing that checks the results is not actually an AI at all. Maybe it's just some kind of deterministic function that determines whether something is good enough based on something that we can calculate or compute. Once we start looking at it this way, we can build much more interesting and much more powerful architectures that abstract the idea of what an agent actually is. One of the libraries that is exploring this is called AutoGen. And this was originally built by Microsoft Research and then open source as well. Originally started in Python, now also actually available in C#. And I want to show you a quick demo of what AutoGen can actually do as well. So let's see. Here we go. The code for AutoGen is actually a lot simpler. All we're going to do is we're configuring. This is just doing a little bit of authentication. And then we're setting up, in this case, 2 agents. We're setting up one assistant agent. This is our large language model. In this case, I think I'm utilizing GPT-4o for this one. And the other one is called a user proxy agent. And this is essentially actually just, this is my laptop. And we can consider the user proxy agent or can configure it in a few different ways. In my case here, I told it to never bother me. I can set the human input mode. If I set this to something else, it might actually act as a real user proxy, so it might ask me a question if it felt like it needed to. In this case, I set it to never, because I just want to see the results. But what you can see here, it's also allowing me to use Docker, and this is because the user proxy can actually run code. Oh, you can see it right here, the code execution config. So the user proxy is able to run the code that the assistant writes. So opposite, or different from the semantic kernel implementation that I just showed you, here I have absolutely no functions, no tools, nothing else that I've written. I could add that, but here I'm relying fully on the assistant agent to actually write the code that I need. And because this is all being executed not in some kind of sandbox in the cloud, like what we've seen with the code interpreter, because this is run here on my laptop, I also can interact with things like local files. I've made this little, we're not installing any extensions right now. I've made this little CSV called Saloon CSV, and it just has some kind of, you could say, like some sales data for some saloons here. And it just has the number of whiskeys that were sold and the number of beers that were sold and so on and so forth. Now, let's say I want to analyze this file. But I don't want to open it in Excel and do something there. I just want to ask my AI assistant to analyze that file for me. Maybe I don't know how to use Excel. Maybe I don't want to use Excel. I just want to interact in a way that's natural to me, and that is natural language. So here, I am initiating the chat between the user proxy and the assistant, and I'm giving it a task. The task I'm giving it is read the Saloon CSV and give me the average for each column. Now, that's not a perfect task, and we'll get to see in a second why that is. If I run this, you'll see a number of things will actually happen. First of all, so we are in a situation now where the two agents are chatting with one another. We as humans are not actually involved. It's the user proxy and the assistant. So my laptop and the large language model. My laptop will tell the large language model, read the Saloon CSV and give me the average for each column. So that is the instruction that I provided. Now, the assistant will reply, to accomplish this task, I will outline the steps needed. It's prompted to do this kind of thing, to make a plan first. It will read the CSV file and load the data. Then it calculates the average for each column in the data set. So far, so good, right? And then it says, here's a Python script that achieves this. And it gives me the Python code. Now it says, funnily enough, it says to my laptop, please save the code in a file named calculateaverages.py, execute it, and share the output with me. Now, the laptop doesn't, understand natural language, but it does that anyway here. It put the code in a file called calculateaverages, and then it ran that. Because we can see this actually here, executing code block number 0. And it inferred that this is Python, so it's going to execute this as a Python file. What it then replies, my laptop replies to the assistant, the execution failed. Oh no. And why did it fail? It failed because, let's just go to the, could not convert Arizona, South Dakota, Kansas, Nevada, Texas, Wyoming, New Mexico, Colorado to numeric. Well, there's one thing I forgot to tell the AI assistant. This file is semicolon separated, right? It assumed this was comma separated, which is why it ended up with the series that was just the individual state names. Now, what you could maybe assume happens now is that it just fails. But it doesn't, because the AI assistant gets this back, and it realizes, well, the script attempted to calculate the mean of non-numeric data, well, which is kind of correct, but we should only calculate the average for columns that contain numeric data. Fair, yeah, okay. So it updates this file, calculate averages, changes things to make sure that it only calculates the average for non-numeric fields, for numeric fields, and then it tries to run this again. Here you go. Now it actually succeeded, but we got nothing. Because we already realized it's not because of the non-numeric fields, it's because of the comma separation. So now the assistant says the outputs indicate that there were no numeric columns in the CSV file, resulting in an empty series. And it says we need to inspect the contents of the CSV file to understand its structure. So it's writing a new Python script here called inspect.csv. Sorry, inspect.csv.py. And this actually just reads the file, and we can see what does it do here. It looks at the data, it looks at the types of the columns. Okay, very good, very good. It's running that, execution of that succeeds, and it gets the first few rows of the CSV file. Very good, all right. Now the penny drops. It appears that the columns in your CSV file are not being parsed properly because the separator used is a semicolon rather than the default comma. All right, very good. So it will now change its original code. And we can see here that it now loads the file with the semicolon as a delimiter. And it executes that again, or my laptop executes this code. And it provides this output to the AI agent, which will then tell us the script successfully calculated the averages for each numeric column, including the saloon number, which is a little funny. But it's doing exactly what it said it was going to do. Every numeric column, and that includes the ID of the saloon. But it gives us the averages, and then it tells us these are the averages of all of the numeric columns. And it terminates. Now, this took a little longer, mostly because we were explaining it. Let's just get rid of that. Oh, it doesn't work. Yep. If we try this again, the interesting thing with this is you never know what happens. While I was hoping something like this would happen, I had no idea it actually would. Let's see how long this would actually take. Okay, so this was actually, if you're running this live, it's actually quite quick. Did it go through the whole Odyssey again with the semicolons, or did it figure it out this time? Because what's important to highlight is, of course, these models don't actually learn anything. Every time I run this, it will see this for the first time. So, but it seems like maybe this time it did it right by accident. Well, regardless, this is pretty quick. So we can suddenly, not only can we build AI agents that can operate with code that we write, and that we know exactly what it does and what happens when we execute it, we can also operate it on code that we let the AI write. And this requires a little bit of trust. This requires some pretty good security as well to make sure that we don't just let it drop tables in our databases and things like that. But for, you could say, like simple operations like analyzing a file, this is actually quite powerful. Because I don't need to know how to write pandas code now to actually be able to analyze the CSV file. I just need to know what it is that I want to achieve. and I need to have the little power of an AI agent that can help me get there. Now, we're getting to the end of the session, so for all of you who made your way here, I've got a little call to action. Because what I often see is when I talk to organizations out there around AI, especially when it's the management types, the corporate types, everybody just wants to build a chatbot, right? Everybody just wants to build something with AI so that their manager stops asking them for when are we going to do something with AI. But I think there are some actual things we can do with AI, and I hope the session today has also shown you that we can actually do a lot more than just have a chat interface that, you know, tells people jokes or recipes or something like that. So if you're working in front end, how many of you work in front end? Great. So if you work in front end, consider how you can actually build more intuitive, natural language-powered interfaces that allow humans to operate software and operate the applications that you're building in a way that's native and intuitive to them, in a way that utilizes the skills that they have. And the skills they have is primarily natural language. Not a lot of humans are born with the ability, well, not a lot of humans are born with the ability to speak, but not a lot of humans learn very easily how to operate software, but humans generally learn easily how to communicate. So leverage that ability. If you work in backend, how many of you are more in the backend? Bunch of you, all right. If you work in backend, consider how you can actually use AI to surface the functionality of your applications through function calling or through giving the user the ability to analyze data, to do whatever, you know, we've just looked at here with code that maybe was even written and authored by AI. The most important thing, really, that I've seen is that what's holding back organizations when it comes to AI adoption is, let's give this a positive spin. What really accelerates organizations when it comes to AI is if they've been doing good development all along. If you have good documentation that is easy for humans to understand and to read, then it's also easy for AI to understand and to read and to use. If your functions are well described to human developers, they will be very well described to large language models as well. And when it comes to APIs and tools and functionalities, if those are modular and if those are easy to call by parts of your application, then they will also be easy to actually make available to AI as well. If you're ready to hit the trail, give some of these things that we've talked about a spin yourself, you can actually click the links in the slide. The slides are shared, so you can just click those. There's some really good learning paths on, for example, using Azure OpenAI, but definitely would also recommend checking out both Semantic Kernel and AutoGen. Those two are, like I mentioned, open source, and you can actually use them with any kind of large language model. It doesn't have to be one that's hosted on Azure, or it doesn't even have to be one that's built by Microsoft at all. With that said, before I ride into the metaphorical sunset, I'll just leave you with one rhetorical question. After all what we've seen today, is this the end of the AI Wild West? Or is it the beginning? Thank you.